Drones are everywhere, from professional filmmaking to industrial applications and even racing. But have you ever wondered how these flying marvels generate lift and stay airborne? It all comes down to one crucial component: the propellers. Today, we're diving deep into the science behind drone propellers, their types, and how to choose the perfect one for your drone. Let's get started. How drone propellers produce thrust? Propellers are devices that transform rotary motion into linear thrust. Drone propellers provide thrust by spinning and creating an airflow, which results in a pressure difference between the top and bottom surfaces of the propeller. This accelerates a mass of air in one direction, providing thrust. More the speed of the propeller, more the thrust generation. To control flight, the propeller speed is adjusted by changing the voltage supplied to the motor, a process handled by an electronic speed controller (ESC). The drone's flight controller feeds the correct signal to the ESC, which relies on inputs from either the human pilot's controller or an autopilot. It may also consider information from an IMU, inertial measurement unit, GPS, and other sensors. Propeller notation. Drone propeller manufacturers usually specify two main measurements, quoted in AXB. The first number is the propeller diameter, and second one is the propeller pitch, both measured in inches. Propeller diameter. Total length of the propeller from tip to tip. Propeller pitch, which is related to the angle of the propeller and is defined as how far the propeller will move forward under ideal conditions for every rotation. Types of drone propellers. Now let's talk about the different types of drone propellers. Fixed pitch propellers. The most common type used in entry-level and mid-range drones. These propellers have a fixed blade angle that cannot be adjusted during flight. They are typically lightweight, cost-effective, and provide a balance between lift and power efficiency. Variable pitch propellers. Also known as adjustable pitch or controllable pitch propellers, these allow the drone's flight controller to adjust the blade angle during flight, improving maneuverability and performance. Variable pitch propellers are commonly used in professional-grade drones, as they offer greater control, stability, and can adapt to changing flight conditions. Folding propellers. Designed to enhance portability and convenience. These propellers can be folded when the drone is not in use, reducing the overall size and making it easier to transport. Folding propellers are commonly found in compact and foldable drones. Self-tightening propellers. Also known as quick-release propellers, these are designed to simplify the installation process. They feature a unique mechanism that allows the propellers to self-tighten as the motors rotate, ensuring a secure fit without manual tightening. Counter-rotating propellers. Commonly referred to as dual-rotor or coaxial propellers, these are used in specific drone configurations. They consist of two sets of blades rotating in opposite directions on the same axis, helping to offset the torque generated by each propeller, resulting in improved stability and reduced rotational forces. The right propeller. Choosing the right propeller is crucial. Here are the key factors to consider. Size. Propeller size is measured in inches and describes the diameter of the circle the blades make as they rotate. Shorter propellers require less energy, easier to control, paired with smaller motors with high kV ratings. Quicker to change speed, suited for fast and quick maneuvers. Whereas longer propellers require more energy, provide greater stability when hovering, paired with motors with low kV ratings, generate more lift, appropriate for carrying heavier payloads. Pitch. Pitch is defined as the traveling distance for a single revolution of the propeller. Pitch refers to the angle of the blades and determines the power the propeller can produce. Low pitch moves less air, hence less thrust, creates less turbulence, produces more torque, requires less power, whereas high pitch moves more air, hence more thrust, creates more turbulence, produces less torque, requires more power. Blade configuration. Drone propellers come in a variety of blade configurations from 2 to 6 blades. In general, propellers with more blades produce more lift and are more stable, but also require more power to operate. Materials used. The material of the propeller affects its performance. Common materials include carbon fiber, glass fiber, military-grade carbon fiber, nylon, nylon carbon composite, polycarbonate, PC, wood. Plastic propellers are cheaper and more flexible, absorbing impact better. Carbon fiber propellers are those stiffer and less durable, reduce vibration and improve flight performance, making the drone quieter. Drone propellers experience two major bending forces. Torque bending, as the motor turns the propeller, resistance from the air creates a bending force. This affects the efficiency of rotation. Thrust bending, the force generated by lift, bends the propeller upwards. Stronger materials help counteract this effect. So, whether you're into drone racing, aerial photography, or industrial applications, understanding your propeller choice can make all the difference. If you found this video helpful, don't forget to like, share,